Welcome, everyone, and thank you for tuning in to Climate Vault's CDR webinar series on oceanic carbon dioxide removal solutions. I'm Bryn Esterly, CDR Projects Manager here at Climate Vault. So a little bit of context for our audience before we get started. Carbon dioxide removal projects have an increasingly important role to play in countering the effects of climate change. In order to achieve the global goal of limiting warming to 1.5 degrees Celsius above pre-industrial levels, we need to significantly reduce the amount of emissions that we're putting into the atmosphere today, while also removing historical emissions that are already in the atmosphere. This is where CDR really comes into play. Scalable CDR solutions enable conscientious organizations to remove historical carbon and also neutralize some of those hard-to-abate emissions from their supply chains or even beyond their value chains. At Climate Vault, we view CDR solutions across three different pathways: oceanic, technological, and terrestrial. In today's session, we'll focus on oceanic solutions that leverage the ocean's function as a natural carbon sink and enhance the carbon sequestration capabilities of critical marine ecosystems, both of which offer promising opportunities to remove atmospheric carbon. With me today are two oceanic CDR project developers who are among the first 10 eligible project developers to apply for Climate Vault's grant funding program to support innovative CDR solutions. Please join me in welcoming Steve Oldham, CEO at Captura, and Sergey Ivliev, founder and CEO at Vlinder. Thank you both for joining me today. To kick things off, I'd like to ask each of you to introduce yourself, your organizations, and tell us a little bit about the CDR solutions that you have currently under consideration for Climate Vault's grant award. Steve, why don't we begin with you? Can you tell us a little bit about Captura and your CDR solution?
Thank you, Bryn, and great to be here and appreciate the opportunity to be on the podcast. I'm CEO of Captura. Captura is a carbon removal company that uses the ocean's natural drawdown effect to remove CO2 from the atmosphere. We came out of Caltech University in California, and basically what we do, we pull CO2 out of ocean water to make room effectively for the ocean to pull more CO2 out of the atmosphere. And that way we leverage this enormous, huge existing capability, the ocean, to help us address the critical carbon removal milestones that we have facing us in the fight against climate change.
Excellent. Thank you, Steve. And Sergey, can you please introduce us to Vlinder and your project that you have under consideration?
Yes, sure. So it's a real pleasure to be here. And Vlinder, we are Austria-based carbon project developer, and our answer to the global climate reversal challenge is the mangroves. So we focus on mangrove restoration globally, and Vlinder, the word comes from the Dutch, means butterfly. So we believe in the butterfly effect of a small action, and for us, this small action is basically restoring mangroves across the globe. And we currently focus on projects in Southeast Asia and Africa, but also expanding to Latin America soon, hopefully. And we're a team of 8 people, and we have 4 projects currently running for the mangrove restoration.
Excellent. Thank you very much both for those introductions. And as we can see just from the differences in your projects, the oceanic pathway encompasses a seriously diverse range of CDR solutions. So I'd like to just pull the lens back a little bit from project specifics here to start and help our audience better understand the challenges and also the opportunities facing solutions in the oceanic space overall. So let's begin first with the challenges. Steve, I'm going to pose this first question to you. What do you see as the unique challenges that solutions in the oceanic pathway face in today's market?
Yeah, so using the ocean is both a fantastic opportunity, but also presents, as you say, some very unique challenges. So the ocean today, it draws down about 30% of all the emissions that we produce as a society. It's a really effective carbon removal device. That's good news from a carbon in the atmosphere perspective. We'd be at over 600 parts per million today already if it wasn't for the ocean. But it's not good news for the ocean. So people will have heard perhaps of ocean acidification, blanching of the coral reefs, the highest temperatures recorded in the ocean in history that were identified recently. So the ocean is playing a really important role, but it's also suffering. So any solution that uses the ocean has the potential to leverage the scale, the existence, the proven capability of the ocean as a drawdown device, but then has a responsibility to make sure that the ocean itself is not affected. We really do not want anybody to think that using the ocean for CDR is accepting that there will be some kind of impact on the ocean. We want the ocean health issue to be considered very, very importantly. So what are the challenges? So many people have an affinity with the ocean, whether it's, we all remember the beach holidays that we had when we were kids, whether it's seeing whales and sharks and the fantastic marine life that we have. Everybody feels an affinity towards the ocean. So it's really important that ocean-based CDR solutions are able to demonstrate that they have no impact. The challenge with that, again, is the size of the ocean. So measuring the impact on the ocean on a very large scale is extremely difficult. So companies like ours focus locally on showing that within the vicinity of a Captura plant, there is no impact to ocean water, and then extrapolating that would be the case on a wider scale as well. So MRV, I'm sure we'll talk about monitoring, reporting, and verification as we go through this podcast, demonstrating benign impact. Captura's approach is based upon the very simple idea that we add nothing to the ocean and we take nothing from the ocean. It's a core principle of our company that ocean health is critical. So as we look at different solutions that impact ocean, ensuring that there's no impact, that it's benign, is really the most important thing. So there's lots of mechanisms to do that, and I'm happy to discuss that, but I'll let you take on the next part of the conversation and then come back.
Sure. Thank you so much for getting us started, and appreciate your perspectives. Sergey, I'd love to hear your thoughts as well. Do you agree with some of the points that Steve has made, or what do you see as the key challenges?
Well, sure. I mean, the ocean ecosystems are like critically important. I mean, basically, they're probably even defining the climate on Earth. And also, like, the way we see oceans is because we work with mangroves, and mangroves are the ecosystems which are on the border between the ocean and basically the land. And they kind of play this key bridge role between those two ecosystems. So, if you know mangroves, they grow in like in salt water, so they have tides coming from the ocean, but they also need some fresh water to be sort of to have to propagate. And from a carbon sink perspective, we're talking about the blue carbons, so it's mangroves and seagrass and coral reefs, which are all kind of one ecosystem. And mangroves, they sequester 5 times more carbon, let's say, per square meter than the terrestrial forest ecosystems. And it's not just the biomass, but it's also a very rich soil carbon sink because they have anaerobic soil like a clay, and CO2 is being able to be stored there permanently for centuries if those ecosystems are left undisturbed. So really, really important, of course, just to preserve them. And it's not easy because 20% of the mangrove cover was already lost in the last 3 decades, and we are increasingly losing it in many countries. And of course, what you have lost, you can reverse, you can restore. And globally, if you look at the possible restorable area, it's north of 1 million hectares, which is possible to restore. I think it's even much more. And IPCC estimates the blue carbon to be a separate kind of CDR class, able to remove around 300 million tons of carbon dioxide per year when it's going ramped up. And what we see now on the market is probably 1/10 of that is available, even less. If you look at the products that we see at Vera, which are registered or under validation. So we want to bring our effort to reach those low-hanging fruits, to increase the restorable area, and potentially also go beyond mangroves, go to seagrass restoration and corals, because they are like one oceanic ecosystem. Really, really important.
It's worth saying, Brendan, certainly I had not understood fully before I took the role at Captura that the very close relationship between the ocean and the atmosphere with respect to carbon. And this comes from something called Henry's Law. So Henry's Law dictates that there is an equilibrium in the gas content between, in this case, the ocean and the atmosphere. So in other words, if you put more CO2 into the atmosphere as we use fossil fuels, the ocean automatically takes its share. It has to re-equilibrate. You know what I mean? So that leads to a increasing level of CO2 in the ocean. But you can also use this effect the other way around. If you pull CO2 out of the ocean, now you're out of equilibrium again, and the atmosphere will put the CO2 back into the ocean. So this very close thing means that really taking CO2 out of the ocean and the atmosphere provide the same climate benefit, no matter which way you do it, because the two systems are so very, very closely linked. And that's something that I hadn't fully appreciated. I don't think yet the wider carbon policy community fully understands either. Carbon credits and policy has been very focused towards direct air capture to date. But removing out of the ocean provides just the same benefits because of this very close equality between the two.
Great, thank you, Steve. And that's an excellent point, which kind of brings me to, when we're thinking about the opportunities that exist in, the oceanic space, what do you see as, key opportunities that these types of solutions offer in terms of addressing the global carbon challenge, and what might set them apart from CDR solutions in different pathways?
So I used to run a direct air capture company called Carbon Engineering, and air capture is a great solution, taking CO2 out of the air. The challenge with direct air capture is at 400 parts per million, you have to move an awful lot of air to capture a meaningful amount of CO2. So air capture companies build machines, they have to have absorbents, and they have to show that they can generate substantial scale. Using the ocean gives you a fantastic opportunity to shortcut. The ocean already exists. It acts as the air contactor. It covers 70% of the surface of the planet. It's been proven in its operation of carbon removal for thousands of years. It's a known asset. It's built. It doesn't cost any capex. It also is an absorbent. So we don't need any chemical absorbents in the Captura solution. So we save significant amounts of money in capital and an operating expense by using the ocean. Going back to your first question, I'm very conscious of when I say that, ocean-focused groups will say, what are you doing with the ocean? It sounds like you just want to use the ocean to achieve this effect, which is why that second point about making sure we don't impact the ocean itself is really important. So for me, the opportunity comes from the fact that the ocean exists at enormous scale. Can we utilize that? CO2 within the ocean is 150 times more volumetrically present than in the air. So for me to move or take CO2 out of the ocean, I have to move 150 times less water than an air capture company has to move air. And I don't need absorbents, and I don't produce any byproducts. So for me, that's the opportunity of using the ocean. It's there, it's proven, it's available, it's free of charge. So can we use it in a way that's benign impact on the ocean and capital friendly?
Thank you, Steve. And Sergey, I'd love to hear your thoughts as well. What do you see as the best opportunities or the types of opportunities that the Oceanic solutions offer?
I mean, speaking of the mangroves specifically, it brings into the picture, not beyond the carbon sinks, so many additional benefits and co-effects, which are not less but sometimes even more valuable than the carbon sink itself. First of all, because you restore this productive ecosystem, which is the mangrove ecosystem, it's can generate. I mean, I've seen estimates that on average it generates around $200,000, ecosystem services per year per hectare, which is I think also quite, X times beyond the terrestrial forest ecosystem, because it has such a rich marine life. So the mangroves, they act like a shelter for like small fish and sea creatures. So that it's like a kindergarten, and the biodiversity is immediately goes rich, and then also you have the communities which live nearby, and normally those are fishermen communities, and they're one of the most poor on earth. Mangroves, they grow around the equator, like 5 degrees, plus minus, and it's typically where like least developed countries, if you look at the map, and they live off the mangroves. They sometimes has to cut them because they didn't have any other way to get the firewood. And if you're able to like restore mangroves and involve them into the project, this automatically gives them, first of all, initially some livelihoods improvement because they participate in the in restoration. But longer term, we employ so-called like benefit sharing schemes, where we, for the full period of the project, like typically 30 years, we create a sharing mechanisms where we every year, once the carbon is verified, the process of the sales are shared with communities, and we have this rule of 50-50 split for the local, stakeholders, communities, so that they benefit long term from the standing mangroves, not just one time plant a tree and forget about it, but have a long term way to ensure that the livelihoods are improved, and they become the stewards of those ecosystems, and they protect it, and educate others about the importance of mangroves. So this just beyond the carbon sink, this brings so many additional benefits like social and biodiversity benefits and marine life improvement.
I mentioned ocean deacidification. One of the additional side benefits of our solution, Captura, we take CO2 out of the ocean faster than the atmosphere puts it back. So what that means is we are constantly ahead of the curve in deacidifying the ocean, because it's the CO2 content in the ocean that drives ocean acidification. So in localized bays, for example, that are affected by ocean acidification, coral reefs, shellfish areas, installing a technology like ours will produce a side effect benefit of deacidifying in a localized area. I emphasize that if you put one of our plants in the middle of the Pacific Ocean, our deacidification impact is a drop in the ocean, if you pardon the pun. But within a localized area where you don't have water mixing continuously, perhaps in a bay or something similar, there you can achieve deacidification because we're always ahead of the game. There are other benefits of using technology-based approaches to ocean carbon removal. For example, we have a lot of ocean infrastructure already. There are 3,500 oil and gas platforms just in the Gulf of Mexico. So there you have infrastructure already on the ocean, already connected with power and generating power, very often on top of a candidate sequestration site, because you can put CO2 into underground used oil and gas reserves, geological formations, saline aquifers. So we can reuse a lot of the infrastructure that we've used for energy generation from fossil fuels in the past, and repurpose them and make them carbon removal devices, which of course also gives ongoing continuity of employment and economics for the communities that are focused on offshore energy generation. So there's lots of benefits to removing CO2 out of the ocean, either through mangroves, through seaweed, through kelp, or through a technological solution like ours.
Thank you, Steve. And I just wanted to return to one point that Sergey had mentioned as well for our audience, just to clarify. So I think sometimes we hear the question, we think of mangrove forests, what is the main difference when you think about the opportunities that they present as a carbon sequestration solution relative to, forests as we think of on land. So Sergey, I'd like to hear kind of your thoughts about what the difference is and how those opportunities might differ.
Yeah, I mean, like from the perspective of the biomass growth, it's quite a similar mechanism. So the trees just grow and sequester carbon by building their own kind of like wood biomass. But mangroves, like as I mentioned, they kind of bring so many more dimensions to the solution. If you look, for example, at like what the key role the mangroves play and for the ecosystem. beyond the biodiversity and like local, population sort of benefits. One of the main thing they bring is the coastal protection, and we've seen clearly, for example, in some areas there where sometimes large cyclones happen or large tsunamis happen, the mangrove cover like really protects the villages from those events. And for example, in Myanmar in 2011 was I think there was a large cyclone Nargis, and it was like the largest casualties were in the areas where the mangroves were clear cut. There was no protection from the ocean, and basically the cyclone just hit the villages, and there was like just officially tens of thousands of people suffered, and those areas, those villages which were they didn't cut the mangroves, they were basically safe because the mangroves are able to stop this wave energy. I think 500 meters of mangrove cover can stop like a large tsunami and basically like dissipate the energy of the tsunami wave. So this is like this coastal protection function is also like it's hard to measure, it hard to estimate, but it's there. And of course the most of the communities which live there, they are, so what we see there on the ground, they are women led, so we mostly employ women to prepare the nurseries and plant the mangroves. Sometimes it's a family exercise, so the whole family basically adopt a hectare or adopt the area and plant their mangroves, because they know that it's the thing they do which will benefit their next generation basically. So those aspects are, I think, really differs mangroves from terrestrial forest ecosystems, which are sometimes pure maximizing carbon thing, without really taking care of the biodiversity and the social impact. So those are things that I think they are even more important than the pure carbon sink.
Great, thank you. And I'm hearing kind of throughout our conversations kind of threads that hit on kind of the social and environmental equity components or considerations for each of these types of projects. So I'd like to shift our focus to the topic of social and environmental equity in the development, implementation, and scaling of oceanic CDR solutions. One of the reasons why feasible CDR is so challenging is that it's not good enough to simply just remove the carbon, right? We need to also ensure that the carbon removal, is being achieved in a sustainable and an equitable manner, and it's not causing undue harm to the communities and ecosystems in which these projects are taking place. And so I'd love to hear from each of you, what kinds of social and environmental factors are you taking into consideration, or do oceanic solutions more broadly need to take into consideration when determining site locations and also implementing projects? And Sergey, I'd love to hand this question to you first. Do you have any thoughts on that?
Yes, sure. I mean, this is how we essentially do the project. So we try to find the areas which has the communities ready to implement the projects. So it's first, and I think it's single most important thing is to find a community which is ready to do the project. And what you see is more and more in the coastal areas, people get more educated about the value of mangroves. Sometimes they have a conflict with the forest because they are poor and they have to cook and build their houses, so they cut the mangroves because of the firewood needs. But if you bring them education, bring them funding for, let's say, creating nurseries, and they can improve the living standards by being engaged in the project, they turn their minds and they start to be protectors of the areas. So the social function is critical. All of our projects are community based and community led by design, and there is no regret, there is no harm for the restoration of mangrove ecosystem, simply because it's a bare land. Typically you find the areas which are kind of degraded. Probably it was a clear cut sometime in the past, or there was some natural disaster which led that this area become deserted and cannot restore naturally because it's maybe too wide or there is not enough species of that kind which can survive. So we analyze those bare lands and we bring the biologists that can help us to create the right mixture of the right species, which has to be planted in those bioland. And then, and this is also, of course, a very important factor to figure this right, because it's easy to plant any tree, but then, of course, the survival will become a critical issue. And we have like good scientists on board and good local scientists. We find which ensure like over 94% survival in our areas. So this is really important. And yes, and the biodiversity improvement, we try to measure that as well. It's important to measure everything you do, and this is where we try to bring novel methods like eDNA. We take water samples and then create a baseline and then measure like how many more species has came into the area, left the DNA traces, so that at least we can show that that there is a biodiversity impact from what we do.
Thank you. And Steve, I'd love to hear from you next. What kind of social and environmental factors are you considering?
Yeah, I think technology solutions inherently come from a sort of a different angle than the types of solutions that Sergey and other bio-focused solutions come from. So for us, inherently a technological based solution is going to require a degree of industry and infrastructure. So to me, I look at it two ways. The first thing is the do no harm principle that I've talked about already. Really, really important that the wider community, the general public, understand that using the ocean as a mechanism to remove CO2 from the atmosphere does not impact the ocean. We're not adding any material to the ocean. There's no byproducts created. We're not changing ocean chemistry. We're not affecting ocean life. The oxygen levels of the water that we return into the ocean are perfectly adequate and good enough for marine life to flourish. So number one, do no harm is really important. So working with the ocean scientists, we already have at the Port of Los Angeles a pilot system working where we're assessing, investigating, and confirming that our system does no harm, and we'll publish all the results from that. And other companies in our sector are doing the same thing. So first, establish do no harm. And then I think the second thing is opportunity. The ocean is enormous. Many countries around the world, in the developing world as well as the developed world, have ocean-based, have ocean shores and have the potential to field ocean-based solutions like ours. So emphasizing the opportunity here, which is an opportunity to employ people in a good industry with a long-term outlook, jobs that make sense for people, that are good paying jobs, energy usage that doesn't conflict with other requirements for renewable energy. One of the challenges for large-scale direct air capture is the energy you need for that, which is large, could be used for other purposes in decarbonization too. Whereas ocean-based systems, the ocean has huge potential to generate its own energy through wave, solar, and wind. So we focus a lot on opportunity, but start with the do no harm. So emphasizing that, educating people. As I said earlier on, I had no idea of the very close relationship between the ocean and the atmosphere with respect to climate. Educating people on that, helping people understand that taking CO2 out of the ocean has a double benefit: deacidification and removal of CO2 from the atmosphere. These things are critical. It's an education exercise. The chemistry is not simple. I like to use my can of Coke example, which I think is worth touching on for a minute, to try and explain things very simply. So this equivalence between the atmosphere and the ocean with respect to CO2 content, you see it every day, every time you open a can of soda. So in a can of soda, the companies that make soda or beer or whatever your preference is, put excess CO2 into the drink so that it's fizzy. When you pour the drink out into a glass and leave it on the table, within half an hour, it's gone flat. It's gone flat because there's too much CO2 in the drink compared to the atmosphere. So all those bubbles that you see coming up is the atmosphere reclaiming the CO2 back, and back it goes into the atmosphere. Very simply, imagine that the other way around. Imagine if your can of soda was CO2 depleted. Now it would draw down CO2 from the atmosphere, and that would help the climate. So that's what our technology does. We have to find ways to explain it in a form that people can understand and appreciate the role it can play. We have to show it has no harm, and then we need to emphasize the opportunity that it can bring.
Excellent, thank you. And I really appreciate that analogy. I think that helps to kind of bring it to life in terms of what you're accomplishing through technology. So thank you for sharing that. I did want to follow up on one item because you had mentioned, I mean, certainly for your direct ocean capture solution, for a technological solution, especially out in open water, if you will, there's so many factors to consider just by the fact that you're operating within the ocean. So how do you even determine what measures need to be in place in order to account for any negative environmental or social harms? Where do you start?
So maybe just to take a step back, very, very simply, our technology draws in ocean water, removes the CO2, and it's a stream of CO2 that we produce. And then it returns the CO2 depleted ocean water back into the wider ocean. And because of Henry's law, the kind of Koch effect, you then get the drawdown. So for us, the critical item is that depleted ocean water that comes out of the back of our plant. Is that a friendly form of ocean water for marine life? So there are standards for this. So for example, in the United States, there is a wastewater standard. You can't just dump water into the ocean. There are criteria you have to pass. So we measure the outflow of our process against those established criteria. Things like oxygen levels, as I mentioned before, the acidity, the pH level, we measure that. That's all extremely measurable. And we can measure it at different points away from the plant as a plume of ocean water, that CO2 depleted, merges with the wider ocean. So it's very straightforward for us to measure that, and we will do, and we will always report on that to ensure that do no harm is met. The second part is, how do you measure the actual drawdown of CO2 from the atmosphere? This is a challenge that a lot of carbon removal solutions have. For example, afforestation. We can certainly address a portion of the climate problem by planting more trees. The problem is, how do you measure the amount of CO2 that a tree absorbs? How do you deal with the fact that the tree eventually dies and returns the CO2 from the atmosphere? So there are economics and structures around the MRV, which I think we'll talk to in a minute. But from the do no harm side of things, it's actually quite straightforward for us to measure and confirm that our outflow is within all standards and perfectly acceptable.
Thank you. And each of you kind of briefly touched on this, so I'd like to dig in a little bit further on this topic in terms of the specific stakeholders that you're engaging with throughout this process, because that's obviously a critical component of implementing, developing any project within the CDR space. So Sergey, I'd love to ask you first, what would you say are best practices for engaging with stakeholders? Or said another way, how do you recommend organizations approach stakeholder engagement?
Yeah, this is super important. Actually, this is what you typically start with, and this is where you can also get your mistakes, at the very beginning, which will be very costly later. So it's critical to engage with, first of all, the communities. They have to be on board from day one, because they are the major stakeholders which live near those coastal ecosystems. The other simply very important stakeholder is the government and the governmental agencies which regulate the land use and the marine intervention. So they have to be, typically you can face kind of forest departments, forest unions in the country. You can face the marine fishery services which regulates that area, and mangroves are sometimes in the intersection of all of them. So you have to get all of the government agencies on board. Then you have to have and we find it's very important to have a solid local partners which can help you to implement the project, because we, for example, we ourselves, we are based in Europe, and it's not just logistically difficult for us to go and plant trees, but also we have a different cultural mindset, and as far as it's much more difficult to navigate those regulation and laws and community relations, which sometimes are very subtle. So we try to find very reliable and trustful partners, build the relationships, and invest in those relationships, so that they then help us to implement the project on the ground. And on the other side, you have the investors, which are the other side of the equation. you need to, make them comfortable, have enough, due diligence and risk management to prove that what you do is like it's solid and it's very well documented, and it's like, let's say, like understandable, like calculatable risk for them to take. Because what they do is they need to give you money to actually invest into like the capex to plant trees, to create nurseries, and 90% of the investments are made up front before the carbon is produced. So you have to make those investors on board, engage them, answer all of their questions. And I think more than half of our effort goes into that. So we kind of get those investor relations, conversations, sales conversations to create structures which are comfortable for investors to come in and participate in the project. And ultimately, you have the standard, like the registry and the validation verification bodies, who make sure that the carbon is measured, and then the carbon credits are issued, which then becomes a commodity, which is tradable and retirable. So like companies and corporates can use this for their claims, like for environmental benefit. And this is also like typically now you have for mangroves, Vera is probably the leading standard, because they have I think most of the products are on Vera. And you have the new standard for blue carbon, which is VM33, which they introduced quite recently. And it's one of the most advanced standards for like blue carbon conservation and restoration. So we use that, and it still has some ambiguities, like how do you measure certain things, like what's the effect of the sea level rise and so on. Like there's many moving parts there. And the VVB, so the validator and verifier, so it's probably the auditor which has to come and measure the biomass growth of the trees, the soil carbon component, has to actually have their educated judgment on if everything goes right, and ultimately sign off certain amount of carbon credits, which they kind of prove were sequestered by mangroves. So this is a lot of elements, a lot of complexity, and we find this like there is a lot of still challenges on the path. And I want to see more projects. I want to see more project developers doing this. And so this is why we're kind of happy to educate and explain what also we do.
Thank you. Yes, that's quite a number of stakeholders to take into consideration. You mentioned governments, local communities, investors, VVBs, so validators and verifiers, standards bodies. Steve, I'd love to hear from you. Are these many of the same stakeholders you take into consideration or have worked with, or how do you approach it?
Yeah, I think Sergey outlined it actually really well. I want to build on two of those stakeholders that Sergey mentioned. So for us, policy is actually quite complex, because the way the ocean works, as you go from the shore outwards, you go through different regulatory bodies and approval givers. So generally very close, it's either municipal. As you move out, it becomes provincial or state. As you move out further, you head into federal waters, and then finally into international waters. So depending upon the location of one of our plants, it's a completely different set of stakeholders who have to give approvals. And that adds a lot of complexity to the situation. So that is one of the challenges of the ocean for sure. And of course, when we go and approach these bodies, they've never heard of any of this. The idea of that they're used to, I don't know, regulating things like wastewater dumping or how marine traffic moves through their regions. This is all new. So there's nobody in these organizations who's thinking of this yet. So this is one of the things that we need more momentum in for sure. The other thing that I wanted to talk about that Sergey mentioned, that the validators, it's right now it's if you forgive me the analogy, it's a bit like the Wild West. There are groups who verify and validate, but they're really doing it to their own standards. They're not UN approved standards or internationally approved standards. And we don't yet have a situation where the world has decided a carbon credit is X. And that creates huge problems, because country X or technology Y may believe that it's generating carbon credits in a perfectly good way, but somebody else may disagree. And then what happens? There's no real definition of that. We saw some of that in Europe recently, where there was a lot of pushback to some of the afforestation credits that have been created. And a lot of large companies that have bought carbon credits that way were left in a difficult situation. They bought them in good faith. And then they're on the front page of the newspapers accused of greenwashing. That stalls the entire industry, because now those organizations are very, very careful and paranoid even in looking at how to buy carbon credits. So we need over time an international definition of what a carbon credit is. And they may come in different structures, a very high quality, which would be the permanent carbon removal, putting it back underneath the surface of the planet, which is, remember where our carbon problem came from in the first place. We took CO2 out from underground and we put it into the atmosphere. Best way to fix it is reverse that process. There may be high quality, permanent credits. There may be lower quality, less permanent, but faster to implement and cheaper credits. When we have an international definition of that, now carbon credits become tradable. Because one of the really interesting things, Sergey's solutions, Captura's solutions will work better in certain places than others. Many countries around the world don't have the ability to sequester or remove carbon. They just don't have the infrastructure in their country. So if a country that has that infrastructure can export a carbon credit to one of those other countries, collectively we can all fix the climate problem a lot easier. There are countries around the world that have huge potential for carbon removal, and that they just need to be able to export a well-defined carbon credit. So this is still a very early stage market. The good work done by people like Climate Vault and others is setting precedent, establishing rules. But the governments and world organizations need to take those on.
Thank you so much for your thoughts on that topic. And certainly there's so much more we could dig into there, but I do want to make sure we hit on our next topic, which has come up in kind of other conversation threads here throughout this discussion, which is monitoring, reporting, and verification. As you both know, MRV is a critical issue for every CDR pathway and project type. And this is because, in order to understand a solution's impact and build trust in that solution, we need to be able to quantify the net carbon removal capacity, confirm the duration of carbon storage, and perhaps most importantly, show that there's no undue harm as a result of the project's implementation. So that's a tall order, and there's a lot of factors to consider, especially when we talk about oceanic solutions. So I'd love to hear a little bit first about some of the challenges that the Oceanic pathway faces in developing effective MRV. So Steve, maybe we can start with you. What do you see as being those greatest challenges to implementing MRV?
So I think you can broadly classify ocean-based carbon removal technologies into sort of 2 or 3 categories. There are some that sequester physically within the ocean itself. There are some that sequester in the biomass within the ocean, like kelp sinking, for example. And there are some that deal with ocean chemistry, like ocean alkalinity enhancement. And then there's solutions like ours, direct ocean capture, that physically removes CO2 out of the ocean. Each of those has a slightly different problem and challenge in demonstrating MRV. So you see different approaches for each sector. For us at Captura, we produce a stream of CO2. So you can measure exactly how much CO2 we took out of the ocean water. So that's an advantage compared to the other 3 solutions which don't do that. However, of course, what we're then saying is by taking CO2 out of the ocean, remember the can of Coke, CO2 will come out of the atmosphere. So the question that gets asked is, well, how do we know that CO2 did come out of the atmosphere? I know you took it out of the ocean, but how do I know it came out of the air? So there are really 2 ways to approach that. The first way is to agree that removing from the ocean is just as good as taking out of the air. That's this interlinking point, Henry's law, all of these things. We're really pleased to see recently that the Department of Energy has a carbon procurement program under formulation, and it will allow removal from the atmosphere or the upper hydrosphere, which is the first 200 meters of the ocean. So that's a step in the right direction for us in showing that removing from the ocean is just as good. If we get to that point, then the fact that I measure the CO2 at Captura It's a gas, it's measurable using standard equipment. Our MRV will be extremely solid in that case. If we have to demonstrate the drawdown from Henry's law, that's a lot harder because the ocean's really big and our ocean water will spread out and over time it will draw down from the ocean. It's really not measurable. You can't measure that. So instead, what you have to do is rely on very close modeling. We have lots of models that show how the ocean has absorbed CO2 from the atmosphere in different regions. It depends upon ocean currents. It depends upon welling within the ocean, whether there's interaction between the shallow and deep oceans. So for us at Captura, what we do, we are working with third parties that build very rigorous ocean models. And we'll locate our plants in areas where we know that the drawdown will be extremely efficient. For example, you don't have downwelling. If our ocean water coming out of the back of the plant gets pulled down to the deep ocean, it never touches the atmosphere. You never get the drawdown. So we need locations, and there's lots of them, where you don't have that drawdown. So using those mechanisms, we can assess and model what we think. And then I think the final thing is what I would call a commercial term, and that's imposing some kind of buffer. So for example, I'm negotiating against myself here for future customers, but let's say we remove a ton of CO2 from the ocean and we measure that ton. Maybe you claim 90% of that as the carbon credit, and you allow 10% for uncertainty, variable factors, because it's just not measurable. So different solutions, different methods. I think we have a pretty good plan inside Captura, but what I really advocate for is this equivalence. Ocean removal is just as good as airborne removal.
Great, thank you. And Sergey, I'd love to hear your thoughts as well on the critical topic of MRV. What do you see as some of the greatest challenges from the mangrove restoration perspective?
I mean, it's really, I agree with Steve. I mean, the carbon credits quality is particularly defined by the MRV quality. So if you measure it right, if you measure the leakage, if you measure the permanence, then you can actually make sure this equality aspect of the credit. And with different methodologies, is different challenges you have. With mangroves, normally the biomass measurement is it's pretty straightforward. Let's say from the traditional forestry, you have the permanent plots and you establish them according to the methodologies, and then you measure basically the diameter, like how the trees grow, and then you measure the biomass captured by the trees and the root system. But as I mentioned, mangroves, the soil carbon component is sometimes maybe 3 to 4 times higher than the biomass capture. So it perfectly makes sense to measure the soil carbon in 30 to a meter to 2 meters height depth, and monitor this in time, because this is a substantial sink as well, and even more important thing. And soil carbon measurement is quite much harder. With the old, again, technologies, you have to drill the earth, then burn the soil samples, estimate the CO2 actually component. This is intense, and we're now trying to find ways to have certain, IoT devices which can potentially measure the CO2, rate, sequestration rate at soil, maybe in real time. Ideally, this will be a system which is fully remote sensing, and you can actually have a very precise estimate of the sink and all of your project area. Ultimately, the things which are beyond the soil carbon, which is, as I mentioned, the biodiversity elements. So we also try to measure that with the eDNA and bioacoustics, some other ways you can capture the living species around your project area. It's not directly it's not directly a separate credit, so it all comes with this 1 ton of carbon sequestered, but it improves the quality of this carbon ton, because you also improve the life underwater and life on land in the area, and of course the social impact. We try now to create livelihood programs, and then what we want to do is the randomized control trials, where we measure the impact of different programs to the population and see how this really affects their living standards. you can do several stuff. You can improve, I don't know, you can build infrastructure, you can create some livelihoods like beekeeping or oyster farming, which can actually, you know, create some small businesses around the area. You can just give a helicopter money, just basically equally, and then you can try to measure what was the real impact of your intervention, what was the true social impact. And this is important to measure and, you know, also verify with like independent third-party verifiers. So yeah, I think MRV is like key most important thing we need to solve for not just Oceanic CDRs, but in general the carbon market.
Absolutely.
So I do want to make one comment on this, just to throw a little bit of a counterpoint in. We also need to understand we are truly in a crisis, an existential crisis in climate, and sometimes perfect is the enemy of good enough. So, you know, for example, if there is a debate about whether our form of carbon capture captures 92% drawdown or 100% drawdown, that's still good. Let's get on with it. Let's worry about whether it's 92, 93, 94, or 95 later. The point is it's still 90 plus. It's a good idea to do. So yes, MRV is important, but we're in a crisis, and sometimes you need to get on with things with all the appropriate checks and balances in with respect to no bad outputs, I'm sorry, and make sure that it has no unfortunate side effects. But fundamentally, anything that removes carbon from the atmosphere is a good idea right now. We're in a crisis.
Absolutely. Thank you, Steve. And thank you, Sergey, for your thoughts. I know we've only scraped the surface here in terms of MRV. This could be a webinar all on its own, but I do want to make sure we have time for kind of your closing thoughts and kind of forward-looking thoughts about the CDR, the Oceanic CDR pathway. So I'd love to ask you, just in conclusion, looking ahead, what most excites you about the Oceanic pathway? Steve, I'd love to hear your thoughts first.
Well, for me, just in the last year or two, the growing recognition that the ocean has a tremendous role to play. I think that's really good because it is an enormous asset. At the end of the day, we need every form of carbon removal we can get our hands on. There is no one solution is better than another. We need them all. So for me, the development of interest and recognition, the White House papers that talk about the role of ocean CDR, the growing recognition in Europe, these things are good because the ocean is a terrific tool that we can use as long as we do so in a way that's environmentally friendly. So that's what encourages me the most. Captura and other companies in this sector are bringing, I think, really promising technologies to the table. What we need is the policy support. Direct air capture has received a lot. I just ask that ocean capture receives the same.
Thank you. And Sergey, how about you? What most excites you about the oceanic space?
Yes, I mean, I very much agree with Steve that we need it all. I mean, we need gigatons, to be on track to be removed. And we see, I don't know, like now millions of tons. So like we are like 3 orders of magnitude less than what we need to just to be on track for like even 2-degree goal, not to say the 1.5, which is probably already missed. So it's and it's challenging. So we need to tackle policies. We need to tackle investments into this area, and we need to tackle like proper like MRV and so many moving elements. And I think the role here is very important for the signaling projects. Like when you have something which works and you show how it can work, and in this environment with non-perfect regulation, non-perfect MRV, and then you can try to scale it up. And my personal dream would be that we can at least restore what was lost in the last 3 decades in the next decade, which can bring us to maybe 1 million hectares of mangroves restored, which can bring us to maybe a few hundred millions of tons of CO2 sequestered annually by 2040, 2050. So, and this is on the way, like to make it, like its own 2 cents into the global problem. And that's what Vlinder is basically, its mission is to try to do this lighthouse projects to show that it's possible, and to bring more investors, to bring more project developers into this area, like to let's over collaborate and solve this problem.
Awesome. Thank you. I think we should wrap on that inspiring note. So thank you very much, Steve and Sergey, for participating in this webinar on Oceanic CDR solutions. I'd also like to wish each of you the best of luck with Climate Vault's RFP application review process, which, as you know, is still ongoing, and wish you well in your carbon removal endeavors. The work you're both doing is extremely important, and we appreciate you taking time out of your day to share your perspectives and experience with us. So thank you. And finally, for our audience, to find out more about Climate Vault's RFP for innovative CDR solutions and to learn how our model can help to reduce and remove your organization's carbon footprint in a quantifiable and verifiable way, check us out at climatevault.com and through the links included with this webinar. Please also check out the other CDR webinar series, which feature applicants across the terrestrial and also the technological CDR pathways. Once again, I'm Brent Esterly, CDR Projects Manager at Climate Vault, here to help make serious climate action your reality.